Hey guys, we are going to continue the second episode of the chapter 3 batteries. In this episode, we are going to connect the batteries in series and parallel or series parallel. Depend what do you need. You need more output voltage, you need to connect the batteries in series. You need more output intensity, more output capacity in amps per hour. In that case, you need to connect the batteries in parallel. Okay. First of all, before you start to connect the batteries, it's important some recommendations. One recommendation is prepare the wrenches that you need per each battery terminal. Normally, the wrenches that you need is a half and a 9/16 or 13 and 14 in a metric size. Okay, prepare the wrenches and isolate the wrenches with electrical tape or any insulator material like this, in order to avoid that in the moment that you use the wrenches, you touch the other terminals and you produce a short. In the moment that you touch both terminals with the wrench, the metal is attracted and it's impossible to separate that metal. The metal becomes too hot immediately, you can burn your hand and you can produce an explosion. Normally the batteries explode. Be careful when you work with batteries. Prepare the tools, isolate the tools, use goggles, use safety goggles, use gloves. It's important. Be careful with the batteries, especially with lead acid batteries. The acid is critical. All right, be careful with your skin. Use appropriate tools, use gloves, use goggles. This is an important recommendation. Okay, the wrenches, isolated wrenches, and prepare the wires that you want to use. Install appropriate the terminals with the insulation material. Check that the terminals are properly installed. Check that the wires have the appropriate terminal properly crimped. I recommend when you work with battery cables, use crimpers, professional crimpers. This is the crimper recommended for battery cables. This crimper is expensive. It's a special crimper, but I recommend this tool in order to install appropriate the battery terminal. The battery cables carry a lot of amps. For that reason, the terminal should be connected appropriately. 90% of the problems related with batteries are because the terminals are improperly installed, because the terminals are corroded, because the terminals are loose with respect to the cable. And it's basically because the people don't use the appropriate tools. I recommend try to buy the appropriate tool. Be careful with the terminals. There are battery terminals. This is the appropriate battery terminal. You see the battery terminal is closed. Is closed over there, and the material is marine approved. This one is open. You see the end is open. When you introduce the wire, the metal of the cable is exposed here and is corroded easily. For that reason, I don't recommend those type of terminals, open terminals, or this one. The people say, no, it's insulated. Yeah, it's insulated, but it's open. It's open. It's not closed like this. This is properly, and this is the appropriate battery terminal for marine applications. This battery terminal is excellent because you crimp it the terminal, and additionally you install the insulation material here with the heat gun. Prepare the cables. Okay, we are going to connect batteries in series. In series, I increase the output voltage. I have an example here. Let me check the example. I have the example here for series connection. This is a series connection. In series, I have two batteries of 12 volts, 100 amps each one. 12 volts, 100 amps each one. Remember, one of the most important part, both batteries should be exactly the same characteristics, the same voltage, the same manufacturer, and the same type of batteries. If this battery is gel 12 volts AEM, gel 12 volts series 27, the second one should be exactly the same, series 27 gel 12 volts, exactly the same manufacturer, exactly the same size, and exactly the same capacity in amps per hour. That's very important. Equal batteries. Okay, in this particular case, I am going to connect those two batteries in series, 12 volts, 100 amp each one. The output voltage increase. What is the meaning of that? The output voltage will be 12 and 12, 24 volts. The intensity when you connect the batteries in series is the same. What happens if I connect 3 batteries in series? The intensity is the same. It's the intensity of one battery. In this particular case, the intensity of each battery is 100 amps per hour. What is the intensity, the total intensity? 100. Doesn't matter if you connect 2 or 3 batteries or 4 batteries in series. The intensity is constant. The output voltage increase. That's the most important part. Okay, in this particular case, the output voltage is 24 volts and the output intensity is 100 amps. Ready? Okay. This is in series. And now we are going to do the connection. Now we are going to start to connect physically the batteries in series and parallel. Okay. Recommendations. First one. The batteries should be exactly the same. What is the meaning of that? Exactly the same type of batteries, gel or lead acid or AGM, all of them should be exactly the same. If you have a group of batteries, all the batteries should be exactly the same type of batteries and with the same capacity. Okay, all of them are gel, and all of them have the same capacity in amps per hour, 100 amps, 100 amps, 100 amps, equal capacity in amps per hour. And the same series of batteries. Okay, all of those batteries are series 27. All of them exactly the same series. Okay, in other words, all the batteries in a group should be exactly the same type of batteries. Alright, we are going to start to connect the batteries in series right now. And after that we are going to connect in parallel. Don't forget, in series, when I connect the batteries in series, both batteries are equal, 12 volts, 100 amps. The series connection is the negative of the first one should be connected with the positive of the second one. And the output of the series will be between this point and this point. In this particular case, the output voltage will be voltage number 1 plus voltage number 2, 24 volts, because the batteries are 12 volts. And the intensity in a series connection, the intensity stay constant. Should be the same, equal to intensity 1, equal to intensity 2, equal to intensity 3, intensity 4. If you have more batteries, the intensity is constant. In this particular case, the total intensity is 100 amps. Alright, and now we are going to do the connection. Be careful with this cable, the cross cable. The cross cable should be properly tied. The color of the cross cable, according with my experience, should be different in order to avoid confusions. Never try to put that cross cable equal than this one red one or equal than the other one black one. In this particular case, I prepared the cross cable green with yellow strips. I mark the color, the positive of this battery connected with the negative of this one, and this is the cross cable. The cross cable should be properly tied with properly wrenches. The output of the series in this particular case is in between this point, the positive of this, with the negative of the last one. How much should be the voltage? I am going to check. I select my multimeter in volts DC, and right now I connect. This is the positive of this, and this is the negative of the second one, and the voltage is 24.69 volts DC. Is clear? One important recommendation. This cross cable, the middle one, should be covered with plastic, with rubber buds. In other words, never try to use any of those terminals in the middle for future connections. What is the meaning of that? In this particular case, this boat is configured in 24 volts. It's because all the groups of batteries in that boat are 24 volts. All the instruments are 24 volts. The engines are 24 volts. The boat completely, the electronics equipments, radar, GPS, transducer, everything is 24 volts. The boat is configured in 24 volts. What happened if one day the owner of the boat said, oh, I want to install the VHF radio 12 volts, only the radio. The recommendation is explain to the customer that the boat, the entire boat is 24 volts. The recommendation is install everything 24 volts. But suppose that somebody want to install an equipment 12 volts. In that particular case, I recommend install a separate battery for that equipment. Never try, because somebody can say, hey, Mr. Lopez, look, in between this point and this point, if I check, I have 12 volts, 12.22. Oh, I am going to suction one cable negative here and other positive here. I have a question, my friends. What is the polarity of this terminal and the polarity of this? Excuse me, this one. Oh, Mr. Lopez, it's negative. No, because it's connected with the positive. Ah, no, it's positive. No, because it's connected with the negative. No, it's nothing. The polarity of this cable is nothing. No negative, no positive. Oh, but when I read between this and this, I have 12 volts. Yes, it's an intermittent 12 volts. It's not a solid 12 volts. If you suction one cable negative from here and other positive, that power is intermittent. If you check with the oscilloscope, you found that is intermittent. No polarity. If you check the equipment connected here, 20 minutes later and you touch the equipment, it's too hot. If you connect from this point and this point one breaker 12 volts, at the end of the day the breaker is too hot. In other words, you can create a fire in a boat if you suction 12 volts from the middle of the batteries, because the middle one doesn't have polarity. That's clear, my friends? Be careful with that. This series is 24 volts and is only for 24. Never touch the middle. And once again, the middle should be properly tied in order to avoid loose terminals. If you have this series connected, for example, for bow thrusters, and the middle cable is loose, when the captain moves or activate the bow thruster, the batteries explode. Be careful with that. This is very important. This is the series connection. One important thing, both batteries equal, the same size, the same capacity, the same manufacturer, equal batteries. That's the first one. And now we are going to connect the batteries in parallel. Finally, checking the series connection. Don't forget the voltage increase. If the batteries are 12 volts, the output voltage will be 24 volts. The intensity will be constant, equal intensity. And what about the power? Power in watts should be, according with the Ohm law, equal to the voltage times the intensity. The voltage 24 volts and the intensity 100 amps. The total power will be 2400 watts. This is for a series connection. In this particular case, the power is 2400 watts. Now I am going to explain the procedure to install the battery terminal on the battery cable using the crimper, the box crimper. Alright, the procedure is, don't forget, try to buy this battery cable cutter. It's a special cutter for battery cables. With this one, you can cut the wire, and also you can cut it only the insulation. What is the procedure? I need to check how much is the distance of the plastic that I need removed. And I am going to remove exactly the same amount of plastic over there. Only cutting the plastic. With this tool, the same tool used to cut the cable is used to cut the plastic. And right now, my wire is ready, and I am ready to introduce the terminal. Before I introduce the terminal, it's recommended introduce the insulation, the heat string. I introduce the heat string, and right now I introduce my terminal. If you check the terminal, all the metal is covered. I don't have metal exposed like this. All the metal should be covered. If not, you remove the material. And right now, I have the crimper ready with the terminal over there. I am going to introduce the cable on the crimper. If you check, this is the crimper, and this is the terminal. I am going to introduce, and right now I am going to crimp it. And we are going to crimp it in other position over there. Okay, right now if you check, the terminal is properly crimped professionally. You can put on the vise and you can try to remove it. And after that, you slide the insulation, and with the heat gun, you apply the heat gun on the terminal. And right now the terminal is properly crimped. The terminal is properly installed. This cable is ready to be installed on the battery. Right now we are going to check the configuration in parallel. In parallel, the negative is connected with the negative, and the positive will be connected with the positive. And this is the output of the parallel, and for positive and negative. What is the meaning of that? In parallel, the total voltage will be equal to the voltage number 1, the number 2, the number 3, the number 4 if you have more batteries connected in parallel. The voltage stays constant. In series, the intensity is constant. In parallel, the voltage is constant. What happens with the intensity? The intensity goes up. Intensity 1 plus 2 plus 3. In this particular case, the total intensity will be 200 amps. And the total voltage, 12 volts, because it's constant. What about the power? For parallel, the total power is the voltage total times intensity total. Is 12 times 200. Is 2400 watts. Okay, we are going to check how is the connection in parallel. Like I explained before, the positive of the first one is connected with the positive of the second one, and the negative of this connected with the negative of this. Okay, what is the advantage of that connection? The advantage of that connection is that the voltage is equal. If I check the voltage here, remember, to check the voltage, you connect your voltmeter in parallel, across the terminals of the battery. In this particular case, the voltage is 12.39 volts DC. And the voltage in the second one, exactly the same, 12.39. And in the third one, 12.39, because the voltage is constant. The intensity right now is 100 of this plus 100 of this is 200. The intensity goes up and the voltage stays constant. In what situation I prefer batteries connected in parallel? When I need more amount of amps for a long period of time. Or, for example, for the house bank. Suppose that you have a sailboat. How should be the connection of the batteries, the house batteries in a sailboat? In parallel. You need a lot of amps, in order to deliver those amps slowly in a long period of time. Parallel. What type of battery should be used for that parallel connection for house bank? Deep cycle or cranking? Deep cycle. Because those batteries deliver the electrons slowly in a long period of time. Why? Because the deep cycle batteries, they have thicker plates, storage more amps, and deliver the amps slowly. That's clear? In what cases I need connect batteries in series? When I need a jump of voltage at the beginning, I need a high voltage for a fraction of seconds during the cranking. During the cranking, you need high voltage for a short period of time. For that reason, the majority of the cranking batteries, the cranking star motors, are configured for 24 volts. There are other situations that we are going to study later where I am going to explain what is better, series or parallel. For example, for bow thrusters. For bow thrusters, you need configurations series for high voltage in the moment that you apply the bow thruster, but also big amount of amps because you need too much amps for a medium period of time. In that case, you configure the batteries in series and parallel. I'm going to explain in our class of auxiliary systems the connection of bow thrusters, windlass, and hydraulic systems, and how can we connect those battery banks. Alright, this is our parallel connection, and now we are going to check. You remember in the previous example how much was the power in series? You remember on the slide that you have right now? Oh, the power is the voltage, the total voltage in series, 24 volts, times the intensity. Oh, in series, the intensity is constant, 100 amps. The total power is 24 times 100 is 2400 watts. 2400 watts. And what happened right now in parallel? What about the power in parallel? The power is 12 volts times 200 amps. It's also 2400 watts. What is the meaning of that? Doesn't matter if the connection of your boat is series or parallel. The power is the same. In the market, you found that too much people that say, "Oh, my boat is 24 volts, more power than your boat, 12 volts." No, the power is exactly the same. The power is exactly the same. Let me explain what is the advantage of one connection over the other one. Okay, this is the connection, this is the power for parallel. And the power for series, the voltage is 24 volts and the intensity is 100 amps. The total power in series is 24 times 100 is 2400 watts. In other words, the power is equal. This is series and this is parallel. What is different here in comparison with this? 24, 100, 12 volts, 200. In parallel, I have more amps. In series, I have less amps. If I have more amps, I need bigger cables, thicker cables, cables with more diameter, heavy cables in parallel. Because I am going to move more amount of amps. In series, I need smaller cables, thinner cables. For that reason, in airplanes, the batteries of the airplanes are configured 28 volts. And the diameter of the wires is small, less weight. Depending on the configuration, in 24 volts, you need thinner cables. In 12 volts, you need thicker cables. This is basically the main difference. Depend of the equipment. In some cases, you need configure in 12 or in 24. That's the pen. We are going to do later some exercises in order to create battery banks configured with the series and parallel together. And we are going to practice with those type of configuration.